Hi, this is Sabita, and this is my team's project, JusticeBot, a virtual legal assistant. So, in today's modern world, the legal domain can often be complex, slow, and difficult to navigate for the general public as well as the legal professionals. So, traditional legal processes are often cumbersome, and it requires individuals to spend significant time and effort searching for relevant case information, legal documents, or understanding the court procedures. So, our project JusticeBot aims to simplify these processes by leveraging cutting edge AI technology. So, about our Project Justice Bot, our Project Justice Bot is an innovative retrieval augmented generation based chatbot designed to revolutionize access to legal information provided by the Department of Justice India. It utilizes advanced language models like Gemini Pro and cutting edge AI technologies. Our Project Justice Bot delivers immediate, accurate, and user friendly guidance across a broad spectrum of legal and judicial services. It simplifies complex procedures by providing detailed explanations and step by step instructions, enabling the users to efficiently navigate their legal needs. The chatbot supports numerous functionalities, including case searches, hearing schedules, court orders, and payment processes. By offering in depth explanations and structured guidance, the chatbot demystifies legal processes, making it easier for the users to handle their legal matters with confidence. So, this is what our project JusticeBot is about. So, our project also highlights the usage of and dealing with the Sustainable Development Goals, Goal 16, peace, justice, and strong institutions, and Goal 10, reduce inequalities by ensuring equitable access to legal information. So, JusticeBot represents an innovative approach for modernizing and democratizing access to justice. So, the problem definition now is that the current access to legal information and services to the Department of Justice website can be complex and time consuming for both legal professionals as well as the public. So, navigating these case status inquiries, court hearings, e filing, and fine payments often requires the users to spend vast amounts of time and go through vast amount of legal information. So, additionally, limited availability of support and guidance outside of the working hours makes it difficult for the people seeking legal assistance or services. So, our solution deals with lack of transparency, delays in case resolution in the modern time, and deals with providing a suitable solution to combat all these problems. So, our project is so robust. It provides instant access to legal services, and it's capable of retrieving large amount of data, answering queries, guiding users through the complex procedures. It is also available 24/7. It supports a large user base, and it's scalable. So, it offers personalized responses to legal inquiries in real time. So, this is our problem definition that we are dealing with. So this is the architecture diagram of our project. So it integrates various components such as the first thing is it splits the large documents into chunks. It generates embedding using the Facebook AI Similarity Search Index, and the vector embeddings of the process data are stored into the face database, and the input embedding as well as the input query text is also converted into vector embeddings and given as an input to the like the database. And this one, along with the Gemini Pro, is used to pull the relevant results from the database in the backend. So the final response is then displayed to the user on the front end, which is developed using HTML, CSS, and JavaScript, and a backend powered by Flask, and a vector store for data retrieval using Face. The front end captures the user queries, which are sent to the backend for processing. The backend, integrated with the Gemini Pro language model, retrieves relevant legal information using Face and formulates responses based on the retrieved information. So this is the working architecture of our project. So I'll start by explaining the processes and code of our project. So, so the project starts by creating an app.py file where the first step is to import the Flask and its related modules to create the web application. So Flask, it's the core class for creating the application, and the render template, it renders HTML templates for the front end, and request, it handles the HTTP request and extracts data sent by the client, and the JSONify converts the Python dictionaries into JSON format for the API responses. The next step is to optimize the scikit-learn operations using Intel's One API for improved performance. So from sklearn x import patch sklearn. So it applies the optimization patch. So we are importing the fits module, which is the model that works with the PDF files such as extracting data and performing OCR operations. So followed by this is the dataset that we use. So which is a basic dataset consisting of all the acts in the Indian constitution, and followed by we are importing a utility for splitting the longer text into smaller chunks while preserving the logical boundaries. logical boundaries, which is done by using LangChain text splitter by using the recursive character text splitter function. Followed by we are loading Google's generative AI embedding model to create vector store embeddings for the text. So we're doing that by from LangChain Google Gen AI, import Google generative AI embeddings. So followed by we are integrating the Facebook AI similarity search library for faster vector similarity search for storing and retrieving the embeddings, which is imported from the LangChain community.vectorstores import face. And then we are importing Google's generative AI chat model for building conversational AI using the chat Google generative AI component. And then we are loading a pre-built question answering chain for handling queries using a defined model, so which is imported as the load QA chain. And the prompt template is created using the langchain.prompts. It allows creating a customized prompt for our AI model. Followed by we are importing the OS and the .env, which is the module to interact with the operating system as well as loading the environment. Next, we are setting up an environment where it reads the environment file to load the environment variables such as the Google API key and initializes the Flask application named app, and then it retrieves the Google API from the .env file, followed by it specifies the current directory containing the PDF files, and the PDF directory is datasets, which consists of all the ACKS datasets. And we are writing some helper functions, and the first helper function is extract text from PDFs. So we are opening a PDF file, and it extracts the text from each PDF and it combines it into a string. And then the second step is we are splitting the text into chunks. So it splits the longer text into smaller chunks using the recursive character text splitter for efficient processing. So each chunk is 500 characters with a 100-word character overlap, and then followed by we're creating a vector store. So the creation of the face vector store process is as follows. It generates the embeddings for the text chunks using Google's model, and it stores the embeddings in the face for efficient retrieval, and it saves the face index locally for reuse. And then we are initializing the vector store. So it checks if the face vector store exists. If not, it reads all the PDFs from the dataset directory, it extracts text, split it into chunks, and creates the vector store. And then we are setting up the conversational chain using the get conversational chain function. So it defines a custom prompt template, and it sets up a conversational chain using the Gemini Pro model, which is a controlled temperature for deterministic responses. Followed by we are handling the user inputs. So the inputs are handled and then they are loaded into the face vector store. It performs the similarity search to find the relevant documents, and then it runs the conversational chain to generate the response. So this is the front end of our project, and it has 3 functionalities, which is instant legal advice, engage document analysis and case management, and 24/7 availability. So this is the working of a project. So we are giving an input, what is the contempt of code ACKS, and let's see what its response is like. So yes, so it retrieves data from that data set and it provides the output for us. So let's go to the next question. What is POSCO Act? So let's see what it gives as the output. Okay, so it generates accurate RAG-based output from the dataset that we have provided instead of giving a generalized output. So we'll just cross-verify with our dataset that we have provided whether the information provided is only from this dataset or is it also giving generalized outputs. And then let's ask another question. When was the Judges Inquiry Act found? Yes, it's giving the correct response and it's keeping it minimal based on the amount of data available in the RAG dataset that we have provided as an input. So in conclusion, the JusticeBot Virtual Legal Assistant we developed demonstrates a significant advancement in providing accessible real-time legal information to users. So leveraging RAG technique, JusticeBot is specifically designed to assist users in understanding and navigating common legal scenarios from contract disputes to basic legal rights. Through testing, our system has shown impressive accuracy and efficiency in retrieving relevant legal information, making it a practical and valuable tool for both legal professionals as well as individuals seeking legal guidance. So, this is the project Justice Spot by our team, myself, Sabita, and Anne Blessy Phillips, and Niranjana Gayatri from Savita Engineering College. Thank you.